My field of research is in a larger branch of physics called medical physics. In particular, I study trace elements using X-rays. If people are familiar maybe with iron, zinc, copper, they are important essential elements. They make up about only 1% of the human body, but they play important roles in different metabolic processes. There are two ways to do this type of research. We can do in vivo research in breathing and living human beings, or we can take tissues ex vivo and scan with very small X-ray beams, only a few microns in size, and we can determine the distribution of these trace elements at the cellular level. And by doing that, it's a unique window to look into molecular mechanisms of various diseases, and there have been a lot of studies looking at Parkinson's, cancer, Alzheimer's, and others. My lab, we mostly do experiments on phantoms, which are basically materials that mimic human tissues. And then after this stage, we move to animal work, and then eventually we move to human experiments. Probably the most success in my field has been in the determination of concentration of lead in bone. So as people might know, lead is a very toxic element. It leads to intellectual deficiencies in children and in adults too. So about 95% of all the lead in the human body goes into bone. So measuring bone lead is actually a much better assessment of long time exposure, total accumulation of lead in the body, comparing to blood lead, which is the current clinical ways. The current projects we have now look at developing a cheaper, portable X-ray method to measure lead in bones, and the research is funded by an NIH grant. If a student is interested in my research, the first thing they can do is contact me via email or phone. Then we'll establish an in-person meeting or virtual. In the first few weeks, I do a lot of one-on-one meeting with a particular student. I introduce them to the subject. If they don't have a background in medical physics, and I do some mini lectures on the topic. I suggest literature searches, papers that I can give them to read at the beginning, or books. And then I introduce them to a particular project. First, the bigger picture of the project, the goals, what we're aiming to achieve, what are the difficulties, and then I assign particular projects. When I meet with them, I typically try to match their skills with a particular project. If they are, let's say, more into data analysis or modeling, I try to match them with a particular part of the project. And they are involved in all the process of research, culminating with writing posters, maybe on papers, summaries, oral presentations, but they are involved from the very beginning in all the entire research process. I think there are multiple skills they acquire, mostly data analysis skill, looking at data using statistical tools. I think the most important part, most important experience they get is to work independently in solving a particular given problem, which I think is a general skill they'll use whatever they go on to do afterwards. As a recommendation to students is, don't get disappointed in the first, stumble in your career. It's gonna happen no matter what you do. You just have to keep going and be persistent and try to overcome. I think research helps them a lot in that regard, discovering who they are, what they can do, what they're good at, and what they can become if they follow certain paths.